Soil genesis deals with the factors and processes of soil formation. Soil layers are approximately parallel to the land surface, and several layers may evolve simultaneously over a period of time. The different layers in a soil are interrelated. However, the layers differ from each other in their physical, chemical, and biological properties. In soil terminology, the layers are called horizons. A vertical exposure of a soil consisting of the horizons is a soil profile. It is important to recollect soil profile description to understand the factors of soil formation. Soil profile is discussed in chapter 1. In this chapter, we are discussing about factors of soil formation. Overview of soil profile. The vertical section of the soil showing the various layers from the surface to the original parent material is known as a soil profile. The various layers are known as horizons. A soil profile is divided into mainly three horizons, namely horizon A, horizon B, and horizon C. A, B, C horizons sit on the bedrock horizon R. The surface layer of soil at the top, which is liable to leaching and from which some soil constituents have been removed, is known as horizon A. The intermediate layers in which the materials leached from horizon A has been redeposited is known as horizon B. The parent material from which the soil is formed is known as horizon C. Above horizon A, upper part of the mineral soil dominated by fresh or partly decomposed organic materials is called as organic horizon or horizon O. Below horizon A, the layer extensively leached by the action of percolating water is called horizon E or zone of alluviations. Therefore, soil profile can be divided into 6 horizons, namely O, A, B, E, C, R. These horizons are subdivided into many sub-horizons and named by prefix or suffix of small case letters of alphabet. Horizons O plus A plus E are called topsoil and horizon B is called subsoil. Factors of soil formation. The soil formation is the process of 2 consecutive stages: the weathering of rock, horizon R, into regolith, the formation of true soil from regolith. The evolution of true soil from regolith takes place by the combined action of soil forming factors and processes. Soil forming main 5 factors are classified into 2 groups. Active soil forming factors like climate, organisms. Passive soil forming factors include parent material, slope or topographic position, and time. One can easily remember these factors by memorizing the mnemonic formula S equals F into COPAST, or soil is a factor of COPAST, where S equals soil, F is factor, C is climate, O is organism, PA is parent material, S is the slope, and T is time. Active soil forming factors. The active soil forming factors are those which supply energy that acts on the mass for the purpose of soil formation. These factors are climate and organisms. Climate. Climate is the most significant factor controlling the type and rate of soil formation. The dominant climates recognized are arid climate. The precipitation here is far less than the water need. Hence, the soil remains dry for most of the time in a year. Humid climate. The precipitation here is much more than the water need. The excess water results in leaching of salt and bases followed by translocation of clay colloids. Oceanic climate. Moderate seasonal variation of rainfall and temperature. Mediterranean climate. The moderate precipitation, winters and summers are dry and hot. Continental climate. Warm summers and extremely cool or cold winters. Temperate climate. Cold, humid conditions with warm summers. Tropical and subtropical climate. Warm to hot, humid with isothermal conditions in the tropical zone. Climate affects the soil formation directly and indirectly. Directly, climate affects the soil formation by supplying water and heat to react with parent material. Indirectly, it determines the fauna and flora activities which furnish a source of energy in the form of organic matter. This energy acts on the rocks and minerals in the form of acids and salts are released. Precipitation and temperature are the two major climatic elements which contribute most to the soil formation. Precipitation. Precipitation or rain is the most important among the climatic factors. As it percolates and moves from one part of the parent material to another, it carries with it substances in solution as well as in suspension. The substances so carried are redeposited in another part or completely removed from the material through percolation when the soil moisture at the surface evaporates, causing an upward movement of water. The soluble substances move with it and are translocated to the upper layer. Thus, rainfall brings about a redistribution of substances both soluble as well as in suspension in soil body. Temperature. Temperature is another main climatic agent influencing the process of soil formation. High temperature hinders the process of leaching and causes an upward movement of soluble salts. High temperature favors rapid decomposition of organic matter and increase microbial activities in soil, while low temperatures induce leaching by reducing evaporation and thereby favoring the accumulation of organic matter by slowing down the process of decomposition. Temperature thus controls the rate of chemical and biological reactions taking place in the parent material. Jenne 1941 computed that in the tropical regions the rate of weathering proceeds 3 times faster than in temperate regions and 9 times faster than in Arctic. Organism and vegetation. Organism. Organisms are in 3 significant groups: living and dead macroorganisms. These include large plants and animals, both living and dead. Plants die and decay, thereby building up organic matter in the soil. The largest contributors are vegetation and animals. Vegetation. The roots of the plants penetrate into the parent material and act both mechanically and chemically. They facilitate percolation and drainage and bring about greater dissolution of minerals through the action of carbon dioxide and acidic substances secreted by them. The decomposition and humification of materials further add to solubilization of minerals. Forest reduces temperature, increases humidity, reduce evaporation and increase precipitation. Animals. Soil animals include large burrowing animals, earthworms, insects, rodents, snakes, and myriapods. Earthworms are the best known animal conditioners of the soil. All of these animals are important because they help mix the soil. Animal mixing carries plant debris that lie on the soil surface down into the topsoil. This makes it easier for the microbes to do their job of changing plant material into humus. Man's activities have significantly altered many areas of natural soils. The chemical and physical properties, particularly of the plough layer, change with cultivation and the addition of lime and fertilizer. Artificial drainage and filling alter the environment of some naturally wet soils. Of all the animals, man can have the most beneficial or most detrimental impact on the soil forming processes. Living microorganisms. These are the source of nearly all organic matter. Microorganisms or microbes have an extremely important role in soil formation. They are the primary decomposers. Bacteria, fungi, protozoa, nematodes, and algae are the major ones. They change raw plant material into a complex, dark brown or black substance called humus. Plant and animal residues go through many changes to become humus. At the same time, they improve soil tilth and release soil nitrogen, which is an essential nutrient that plants need in large quantities. Thus, many topsoils are rich and fertile because they are well supplied with humus. Microbes and the humus they produce also act as a kind of glue to hold soil particles together in aggregates. Well aggregated soil is ideal for providing the right combination of air and water to plant roots, as well as improving soil tilth and decreasing susceptibility to erosion. Without microbes, soil would be a virtually inert, lifeless body. Finely divided non-living material. Non-living soil organic matter is a small but critical component of soils, contributing to soil structure, fertility, and a range of other chemical, physical, and biological functions. Organic matter includes plant and animal residues at various stages of decomposition. Humus is the portion of the organic matter remaining after the major part of plant and animal residues have decomposed. It is usually amorphous, formless, and dark brown or black. The finely divided non-living materials are the major components of soil humus. Addition of organic residues and mixing them with minerals promote the differentiation of soil profile. Passive soil forming factors. The passive soil forming factors are those which represent the source of soil forming mass and conditions affecting it. These provide a base on which the active soil forming factors work or act for the development of soil. Parent material. It is that moss or consolidated material from which the soil has formed. The parent materials are classified into two groups. Sedentary parent material. Formed in the original place, it is the residual parent material. The parent material differ as widely as the rocks. Transported parent material. The parent material transported from their place of origin, they are named according to the main force responsible for the transport and redeposition. Parent materials transported by gravity are called colluvial, by water alluvial, moraine, lacustrine, by ice glacial, by wind aeolian. Colluvium. Colluvium is the general name for loose, unconsolidated sediments that have been redeposited at the base of hill slopes by either rain wash, sheet wash, slow continuous downslope, creep, or a variable combination of these processes. Colluvium is typically composed of a heterogeneous range of rock types and sediments ranging from silt to rock fragments of various sizes. This term is also used to specifically refer to sediment deposited at the base of a hill slope by unconcentrated surface runoff or sheet erosion. Alluvium. The material transported and deposited by water found along major stream courses at the bottom of slopes of mountains and along small streams flowing out of drainage basins. Alluvium is relatively homogeneous sediments at the base of hill slopes, including basin fill. The large degree of sediment sorting indicates transport by water. The size of the particles would be limited to what the surface flow of water is capable of carrying in that environment. Lacustrine. Lacustrine consists of materials that have settled out of the quiet water of lakes. Moraine consists of all the materials picked up, mixed, disintegrated, transported and deposited through the action of glacial ice or of water resulting primarily from melting of glaciers. Lios or Olean. These are wind-blown materials. When the texture is silty, it is called loess. When it is sand, aeolian. The soils developed on such transported parent materials bear the name of the parent material, namely alluvial soils from alluvium, colluvial soils from colluvium, etc. In the initial stages, however, the soil properties are mainly determined by the kind of parent material. Endodynamomorphic soils. Endo means within. In this type, soil properties are mainly influenced by the type of parent materials. Different parent materials affect profile development and produce different soils, especially in the initial stages. Acid igneous soils like granite produce light textured soils like alphisols. Basic igneous soils like basalt produce fine textured cracking clay soils like vertisols. Basic alluvium or aeolian materials produce fine to coarse textured soils like entisols. The nature of the elements released during the decaying of rocks has a specific role in soil formation. Example, silica and aluminium form the skeleton for the production of secondary clay minerals. Iron and manganese are important for imparting red color to soils and for oxidation and reduction phenomena. Sodium and potassium are important dispersing agents for colloids. Calcium and magnesium have a flocculating effect and result in favorable and stable soil structure for plant growth. Ectodynamomorphic soils. Characterized by the changes brought about by external as well as climatic forces or agencies. Slope or topography or relief. The relief and topography and slope sometimes are used as synonymous terms. They denote the configuration of the land surface. The topography refers to the differences in elevation of the land surface on a broad scale. Slope influences the amount of runoff, the rate of water infiltration, the rate of leaching, the movement of clay, and the thickness of the developed soil. In steep areas, runoff is rapid and very little water passes through the soil. As a result, soil formation is slow. In gently sloping areas, runoff is slow, erosion is minimal, and most of the water passes through the soil. The infiltration of water intensifies leaching, translocation of clay, and other soil forming processes. The prominent types of topography designations as given in FAO Guidelines 1990 are as follows. They are classified into 7 categories depending upon the percentage of slope or gradient. Flat to almost flat if the land is having 0 to 2% gradient. Gently undulating 2 to 5%, undulating 5 to 10%, rolling 10 to 15%, hilly 15 to 30%, steeply dissect greater than 30% with moderate range of elevation of less than 300 meters. Mountainous greater than 30% with great range of elevation of greater than 300 meters. Soil formation on flat to almost flat position. On level topographic positions, almost the entire water received through rain percolates through the soil. Under such conditions, the soil formed may be considered as representative of the regional climate. Soil formation on undulating topography. The soils on steep slopes are generally shallow, stony, and have weakly developed profiles with less distinct horizons. It is due to accelerated erosion, which removes surface material before it has the time to develop. Reduced percolation of water through soil is because of surface runoff and lack of water for the growth of plants, which are responsible for checking of erosion and promote soil formation. Soils at the bottom of a hill are different from soils at the top or sides of a hill. Rainwater infiltrates the soil at the top of the hill, but the slope causes the water to rush down the sides of the hill as runoff. Soils at the bottom of the hill will be wetter and more developed than soils on the top or the adjacent slopes. Soil exposure also influences soil formation. The direction of the slope also affects the soil formation by affecting temperature and vegetative growth through slope exposures. The southern exposures facing the sun are warmer and subject to marked fluctuations in temperature and moisture. The northern exposures, on the other hand, are cooler and more humid. The eastern and western exposures occupy intermediate position in this respect. Time. Soil formation is a very slow process requiring thousands of years to develop a mature peat-on. The period taken by a given soil from the stage of weathered rock, that is regolith, up to the stage of maturity is considered as time. The matured soils mean the soils with fully developed horizons A, B, and C. It takes hundreds of years to develop an inch of soil. The time that nature devotes to the formation of soils is termed as pedological time. It has been observed that rocks and minerals disintegrate or decompose at different rates. The coarse particles of limestone are more resistant to disintegration than those of sandstone. However, in general, limestone decomposes more readily than sandstone by chemical weathering. Based on the weathering stages in soil formation and their characteristic features are as follows. 1. Initial unweathered parent material. 2. Juvenile weathering started but much of the original material is still unweathered. 3. Virile, easily weatherable minerals fairly decomposed, clay content increased, slow weatherable minerals still persist. 4. Senile decomposition reaches at a final stage, only most resistant minerals survive. 5. Final soil development completed under prevailing environments. The soil properties also change with time. For instance, nitrogen and organic matter contents increase with time provided the soil temperature is not high. Calcium carbonate content may decrease or even lost with time provided the climatic conditions are not arid. In humid regions, the hydrogen ion concentration increases with time because of chemical weathering. Summary. Soil genesis deals with the factors and processes of soil formation. Soil forming main 5 factors are classified into 2 groups. Active soil forming factors like climate, organisms. Passive soil forming factors include parent material, slope or topographic position and time. Directly, climate affects the soil formation by supplying water and heat to react with parent material. Indirectly, it determines the fauna and flora activities which furnish a source of energy in the form of organic matter. Organisms are in 3 significant groups: living and dead macroorganisms, living microorganisms, and finely divided non-living materials. Passive soil forming factors are divided into endodynamomorphic and ectodynamomorphic factors. Slope is an important factor. FAO has classified slope into 7 categories based on the percentage of gradient. Direction of the slope also plays an important role in soil formation. In time scale, young soils inherit the properties of their parent materials. They tend to have the color, texture and chemical composition of their parent materials. Later on, the influence of the parent materials is not as evident. The influence of time will vary with the kind of parent material. Some parent materials weather faster than others. Also, climate may change over time. These 5 factors of soil formation are so closely interrelated in their effects on the soil. Soil forming factors are not always present in the same intensity and degree. Thus, there are many differences in soils. Soils that formed at the same time from the same parent material can be different. The factors do not act independently. Interaction among different factors itself creates numerous permutations and combinations of factors affecting soil formation. Thank you.